Day 61 of doing a LeetCode problem every day until I get a job. All right, guys, we're back again. Another day, another LeetCode problem. I hope you guys have been following along and keeping up with this channel, guys, and I hope you've been learning something. Now, with that being said, guys, don't forget, bring a mouse, bring it right over here and click that subscribe button for me. Then after you click that subscribe button, go ahead and smash that like button for me, guys. Then after you smash that like button for me, guys, go ahead and go to the comment section and drop that bank emoji in the comments. I need all of my bankers out there to go ahead and drop a bank emoji in the comments so we can run this engagement up and bring more awareness to the Swift community, and we could get everybody excited about learning how to write code in Swift. Now, with all that being said, guys, I know why you're here. You want to get to the question and the solution. So, the part you've all been waiting for, the question. Today we have question number 1926, nearest exit from entrances maze. The difficulty level is medium, guys, but don't be deterred. Don't let that scare you. We're going to get through this, and we're going to keep it as simple and easy as possible so that we all can learn and understand what it is we're doing. So, let's see what the question says. It says you are given an m times n matrix maze 0 index with empty cells represented as a period, and walls represented as a plus sign. You are also given the entrance of the maze where the entrance equals entrance row, entrance column, denotes the row and column of the cell you are initially standing at. In one step, you can move one cell up, down, left, or right. You cannot step into a cell with a wall, and you cannot step aside the maze. Your goal is to find the nearest exit from the entrance. An exit is defined as an empty cell that is at the border of the maze. The entrance does not count as an exit. Remember, the number of steps in the shortest path from the entrance to the nearest exit, or -1 if no such path exists. So, what they want us to do, guys, is they want us to find the shortest path to an exit and return the number of steps up. So let's see, let's look at example 1. So if you look at the picture, you see this is the shortest. This exit right here requires the least amount of steps. We could just move up 1 instead of going to the left 2, right? So, and we can't use this as an exit because there's no way of getting there, and the entrance does not count as an exit. So only thing we could do is move up one, and that will be the shortest path. So that's why the output is 1. However, let's look at these. Let's go through this so we all understand what this is talking about, because as we're programming, this is what we're going to see. We're not always going to have a picture. We might just have an input that looks like this. So let's go through the input so it makes sense. So this right here represents row 1, right? So, or row 0, I should say. And I don't know why the index starts from the top, but it does. So this right here, this array right here starts as, remind you, this is a 2D array that contains arrays inside of an array. So this first array right here represents row 0. So if you look, it goes plus, plus, then it's a period for the exit, or what does it say? With empty cells. So yeah, so this is an empty cell, that's why it's a period. So it goes plus, plus, period, empty cell, plus. So the plus is equal to brick walls, the periods equal to empty cell. So then we come down to row 1, which would be this row, and then it goes period, 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 because they're all empty cells, plus sign, because this is a brick wall. So these brick walls are the plus signs, these empty cells are the periods. Then we move down to row 2, it goes plus, 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 period, because it goes brick wall, brick wall, brick wall, period. And remember, the plus signs equal to brick walls, the period equals the empty cell. So, okay, now let's look at the entrance. The entrance equals 1 and 2. So I don't know why it starts at 0. I don't know why the top is 0, but the top is 0. So this is 0, this is row 0, this is row 1. So we come down to row 1, then we come over to column 2, and this is 0 too. So this is 0 and this is 0 as far as indexes. This is the 0 column and this is the 0 row. So the top is the 0 row, the farthest left is the 0 column. So we come down 1, so now we're at row 1, and then we go over to column 2. So we come down row 1, 1, 2. Now we're column 2. That's where this 1, 2 comes from, guys. The output is 1 because that's the shortest distance to an exit. We just need to go up 1 and we're at an exit. The explanation, let's go through the explanation. So just in case it's not all making sense yet, it says there are 3 different exits. There are 3 different exits in this maze. 1, 0, then it's 0, 2, then it's 2, 3. So this would be uh, 1, 0. Excuse me. This would be 1, 0. Because this would be 0, 2, and this would be 2, 3. So it says initially you are at the entrance cell 1, 2. You could reach 1, 0 by moving 2 steps to the left. So remember, we start from the top. So this is 1. This is 1, column 0. You could get there by 2 steps to the left. It also says you could reach 0, 2, row 0, column 2 by moving 1 step up. Boom. So row 0, this is row 0, and you go over to row 0, 1, 2. You just need to move 1 step up. It is impossible to reach 2, 3 from the entrance. So this is 2, 3. Remember, we come down 1, 2, then we go over 3. 1, 2, 3. It's impossible to reach because there's no empty cells that allow us to reach it. Thus, the nearest exit is 0, 2, which is 1 step away, which is why the output is 1. So let's look at example 2. Example 2 is a little easier. It's the same thing. First row, all plus signs, all brick walls. Second row, all periods, all empty cells. Third row, all plus signs, all brick walls. Entrance 1, 0. We come down over 0. That's the entrance. The output is 2. Why? Because it takes us 1, 2 steps to get to the exit. Explanation: there's one exit in this maze at 1, 2. Come down 1, 1, 2. 1, 0 does not count as the exit since it's the entrance cell. Initially, you are at the entrance cell 1, 0. You could reach 1, 2 by moving 2 steps right. Thus, the nearest exit is 1, 2, which is 2 steps away, which is why the output is 2, because that's the shortest distance we could take to get to an entrance. And then this, same thing, except this is -1 because there are no, so when there's no exits, remember the entrance cannot be an exit. So this has no exits. When there are no exits, we return -1. Excuse me, guys. We return -1, and that comes from up here where it says return the number of steps in the shortest path from the entrance to the nearest exit, or excuse me, we're gonna say or -1 if no such paths exist. And that's why in example 3 the output is -1. So now that we have broken down what the question is asking, it's time for the fun part, guys. Let's get into the code. The first thing we're going to do is we are going to declare a variable called neighbors, and we're going to set that equal to, it's going to be a 2D array, guys. So it's going to be arrays inside of array, because we have to do excuse me, these are going to represent the directions we can go. So we're going to do 1, 0. Then we're going to come over here, still inside the big array, but with this is a separate array inside of the big array, right? So then we're going to do 0, 1. Then we're going to come outside that, but still in the array, and then we're going to do another one, and we're going to go 0, -1. Then we're going to do that one more time. Stay in the array, and open up new array brackets, and that's going to be, -1, 0. And these are going to represent the directions we can move. Then we're going to declare another variable called visited. Excuse me, guys. I don't know what is going on with my spelling. Visited. And we're going to set that equal to maze, which comes from up here. Excuse me. Then we're going to come down here and we're going to say var, declare another variable. We're going to call this Q, and we're going to set that equal to an array. Then we're going to go like that, and we are going to say X and comma Y and comma step. And this is going to keep track of where we are and how many steps it takes to get to the entrance. And then got to initialize that. Don't forget to initialize it. Then we are going to come down here and we are going to say q, q dot append. Then we're going to open up two parentheses and we are going to say x colon entrance index 0. Then we're going to come over here, do the same thing for y, except this time we're going to say y colon entrance, and we're going to say index 1. Then we're going to come over here and we're going to do one more time. We're going to say step colon 0. Then after that, we're going to come down here. We're going to say visited entrance index 0. Then we're going to come over outside of that, open up a new array brackets, and we are going to say entrance index 1 equals, then we're going to put the plus sign inside of these parentheses. Then after that, we're going to, then after that, we're going to say while exclamation point q is empty. And what that means is while the q is not empty, then we're going to say declare a variable called cur, and we are going to set that equal to the q dot remove first. Excuse me. Then we're going to say for neighbor and neighbors, we're going to declare a variable called x equals cur dot x plus neighbor index 0. Then we're going to come down here and do the same thing for y. We're going to say declare a variable called y. We'll set that equal to cur dot y plus neighbor index 1. Then we're going to come down here and we are going to say if x is greater than 0 or less than 0, or y is less than 0, or x is greater than or equal to visited dot count, or y is greater than or equal to visited index 0 dot count, then then we are gonna come, excuse me guys, then this dot count should be outside of that index marker. So then we come over here and we are going to say if, open up the parentheses, cur dot x equals entrance index 0 and cur dot y equals entrance index 1, then then we are going to come out here and we are going to come down here and we are just going to say continue. Then we're going to come down here, we're going to come underneath that, we're going to say return cur dot step. Then we're going to come underneath that and we're going to say if visited index x index y equals a period, then what we are going to do is we're going to say visited index x, and we'll come over here, say index y is equal to a plus sign, so that we know we have visited that cell already. Then we're going to come down here and we're going to say q dot append, then we're going to say x colon x, comma y, colon y, comma step, colon cur dot step plus, plus 1. Then we're just going to come down here and we're going to return -1 in case there's no exit for us to find. Now, let's run it and see what happens, guys. See what happens, guys. Fingers crossed, fingers crossed. Okay, line 23, it says instant method append expects a single parameter in solution. So let's see what we have, what's going on here, guys. So it says, oh, so let me see. Hold on, guys. Give me a minute. Give me a minute. Oh yeah, guys. So this should be a the parameter should be, we need to add 2 more parentheses right there. So let's see what happens when we run it again. And it's accepted, guys. That's what I'm talking about. So let's submit it and see what that time is looking like. Let's see, guys. Let's see, guys. 505 milliseconds beats 88.17% of users. That is not bad, guys. Not bad at all. This was a little different type of problem that we've done before. I know if you guys are into gaming, you might like this problem. So, hey, I wish you guys the best on your programming journey if you're making games. That's not what I'm trying to do, but I'm all for it if that's what you're trying to do. And until next time, guys, I'll see you then for another day, another LeetCode problem. Peace.